Hello and welcome back. Today we've got a very exciting tutorial. We're talking about the logistic regression. The logistic regression is used to predict a categorical dependent variable from a number of independent variables. So the key difference to a linear regression here is that we're not predicting a continuous variable, we're predicting a categorical variable. For example, you might be working for an insurance company and you want to predict, will somebody purchase the health insurance that your company is offering, yes or no? And it's very simple, yes or no. It's a categorical variable, and you might want to be predicting this dependent variable based on an independent variable such as age. So depending on their age, will they purchase the health insurance plan that your company is offering? So on the x-axis we would have age, on the y-axis we would have yes or no, did they take up the offer or not. Let's say our x-axis is somewhere between 18 years of age and 60 years of age, and our y-axis simply has binary outcomes, yes and no. So there's no in-betweens, it's either yes or no. So we're going to just add this horizontal line for illustrative purposes. So what will our data set look like? Let's say we've got a certain number of observations in our data set, so we know people's age and we know when they were exposed to the offer, whether they purchased or didn't. So these people over here didn't purchase the health insurance, and these people over here did purchase the health insurance, and that's our data set. So as you can see, it's very different. This plot looks very different to what we were working with in the linear regression tutorials. So we can't simply draw a linear regression line, a sloped a line through these points. It makes no sense. So that's why the equation for logistic regression is slightly different. Here it is. So here on the left, we've got, instead of y, we've got a logarithm, and then on the right, we've got the same part as we saw before. The important value to us here is p, and that is the probability that we'll be working with just now. We'll see it in action. So let's look at the logistic regression curve. The logistic regression curve looks like this, and it's also called the sigmoid curve. And how does this work in action? Well, let's say we have two new observations. Let's say we've built this model based on this data. We have a logistic regression. How will it apply to new observations? Well, let's say we have two new observations, somebody of age 35 and somebody of age 45. What we do is we will need to project these values onto our logistic regression, find out where they fit there, and the logistic regression will give us probabilities. So this value, everything here is between 0 and 1. So no is a 0, yes is a 1, and in between are the probabilities. So the logistic regression gives us probabilities of somebody saying yes, of somebody taking up that offer. So for the 35-year-old, it's a 42% chance that they will take up the offer based on this model. So this is what the model is predicting. It's predicting a 42% chance they will take up the offer. And for the 45-year-old, there's an 81% chance they will take up the offer. So we could stop there. That is the P, that is the probability that we see in the equation on the left, that's hidden inside that logarithm. So we could stop there and we could use these probabilities, and that in some use cases, that's what the logistic regression is used for. We just deal with the probabilities once we have them. But in most cases, we want a binary outcome, a yes or no outcome. And so for those situations, we split our curve into two, our plot into two. Anything above this line, this middle line, anything above with a probability of 50% or higher will be projected into a yes, into a binary 1, and anything below the 50% line will be projected into a no, a binary 0. Our points would end up here. So based on this logistic regression, we would make the conclusion that the 35-year-old would not purchase our insurance plan and the 45-year-old would purchase our insurance plan. And just like with linear regression, you can have multiple independent variables. So for instance, age, income, level of education, how big their family is, or whether they have a family or they're single, and many other types of variables can be added depending on the use case. And our equation will look like this in this situation. So there you go. That's logistic regression in a nutshell. I look forward to seeing you next time. And until then, enjoy machine learning.